In this video, we're going to be talking about counting with geometry and counting with symmetry, so let's get started. So this video is going to be about symmetrical counting, and it's a type of counting. So when we have symmetrical counting, when we count with symmetry, we have different ways we can do it. And this is basically an extension of permutation. So let's say I have a round table in which there are 10 people. And there's 2 more to seed randomly. And we want to know how many ways we can arrange 10 people on a round table. So immediately we should just do 10 factorial, since that's how many ways we can arrange 10 factorial people, 10 people on a round table, because, 10 choice of the first seat and so on, but this is a round table. So let's say if this is A, B, C, D, on a round table I can rotate this and I can have D, C, B, A, or some other combination, or some other, not combination, but another thing. So let's look at a smaller problem. If I just flip this round table, I can have A on the bottom, I can have C at the top, I can have B at the side, I can have D over here. So there's multiple ways we can do this, and especially since we notice that if we try the problem with 4 people in a round table, we're going to have 4 factorial, but then this is counting everything 4 times, because if on a round table, some things are the same as others. So we can rotate this and it'll count everything 4 times. So to correct for this, we just divide by 4 and we get 3 factorial. And that's our answer for the 4 table. So now we can go over to the 10 table, and obviously this counts everything 10 times. So we can divide by 10 to get 9 factorial as our answer. Now let's look at another problem and go more in depth. Let's say we have a round table and there's 5 people. So when there's 5 people, the first thing you want to do is use permutations and just count a 5 factorial, since treat it as if it was a regular table and not a round table. Now, since it's a round table, as I said, we can rotate this table and have the same exact count 5 times. And 5 factorial divided by 5 is just 4 factorial. And that's just 24. So our answer is 24. And anytime we have this, we notice a pattern. So when we count with symmetries, our formula is n factorial divided by n. So counting with symmetries, we have that formula. So keeping this formula in mind, if we keep this formula in mind, there's multiple things we can do with this, and let's try a different type of problem here. Let's say we have 5 people again. Let's do 5. But this time we have 5 people, but 2 people say that they won't sit next to each other. And whatever happens, they will not sit next to each other. So over here, we can draw this out. And then we can have 5 anywhere we want, honestly. Over here, let's say. Or if we try to draw this in terms... Yeah, so we can have it like this. So over here, 2 people will not sit next to each other. So what we want to do here is 1, 2, 3, 4, 5 people, and 2 people will not sit next to each other. So if the first person takes a seat, the first person has 5 choices, right? Person 1 sits down, and that person has 5 choices. And this is one of the people who does not want to sit next to person 2. So when person 2 arrives, person 1 takes 1 seat, and now person 2 can't sit in this seat. Can't sit in this seat because it's next to person 1. Can't sit in this seat. So person 2 just has 2 choices. So we multiply by 2. That's how we do it in counting. And then the rest of the people, they can sit anywhere they want. But now we have 2 seats that are occupied. So they have 3 factorial ways, which is just, so we have 3 factorial. And it's a round table. Remember our formula, n factorial divided by n. We use the same thing here. 5 is our n. Counting everything 5 times, so that's what we do. And the 5's cancel. So we have 2 times 3 factorial, and 3 factorial 6. Our answer is 12. Now, let's try one last type of counting problem with symmetries. Let's say we want to see how many ways we can have let's say accessories on a keychain versus the ones you can get at gift shops. So here we can do the same, use a similar formula. We start off with n factorial divided by n. And so first we start off with a 3 factorial. And this is a symmetrical object, so we can divide by 3. But the thing here is, it's a keychain. So in the next video, I'll go over this, and we'll cover this all. So in the next video, we'll find out how to solve this problem, and I encourage you to try this problem on your own before watching the next video. Hopefully it's helped, and that is symmetrical counting.